The evolution of the universe. From the Big Bang to the present. Imagine the entire history of the universe, all 13.8 billion years of it, compressed into a single calendar year. January 1st marks the Big Bang, and December 31st at the stroke of midnight is right now, the present moment. On this timescale, human history occupies just the last few seconds. But what a journey it has been. From the fiery birth of the cosmos to the formation of galaxies, stars, and planets. The universe's story is one of constant evolution, epic events, and unimaginable scale. In the beginning, there was nothing. No space, no time, no matter. Then, in a fraction of a second, everything changed. Approximately 13.8 billion years ago, the universe was born in an event known as the Big Bang. This wasn't an explosion in space. Rather, it was the rapid expansion of space itself, from an unimaginably hot and dense state. In the first moments after the Big Bang, the universe was a seething soup of energy. Temperatures soared to unimaginable levels, billions of degrees, and particles that would later form matter didn't even exist yet. Instead, this early universe was a quark-gluon plasma, a chaotic state where even the most fundamental building blocks of matter were indistinguishable. Then, as the universe expanded and cooled, a profound transformation occurred. Quarks combined to form protons and neutrons, and these particles began to assemble into the nuclei of the first elements, hydrogen, helium, and a dash of lithium. This epoch, known as Big Bang nucleosynthesis, laid the groundwork for all the matter that would later form stars, galaxies, and planets. With the birth of the first elements, the universe entered a period known as the Cosmic Dark Ages. The searing glow of the Big Bang faded, leaving the universe in darkness. There were no stars, no galaxies, just vast clouds of hydrogen and helium drifting in the growing void. But within this darkness, something remarkable was happening. Gravity, the invisible force that would shape the future of the universe, began to take hold. Over hundreds of millions of years, tiny ripples in the density of matter left over from the Big Bang began to grow. These ripples were the seeds of the first galaxies, but their formation was still billions of years away. This period was marked by anticipation, a universe filled with potential but still waiting for the spark that would ignite its transformation. At last, approximately 400 million years after the Big Bang, the darkness was pierced by the first light. This was the era of rionization, when the first stars ignited, marking the end of the cosmic dark ages. These first stars, known as population 3 stars, were unlike any we see today. They were massive, short-lived, and incredibly bright, composed almost entirely of hydrogen and helium. As they burned through their nuclear fuel, they began to produce heavier elements like carbon, oxygen, and iron, elements that would be crucial for the formation of planets and eventually life. But these stars lived fast and died young, ending their lives in spectacular supernova explosions. These explosions didn't just destroy the stars, they also seeded the surrounding space with the heavy elements needed for future generations of stars and planets. In the aftermath of these first supernovae, gravity once again took center stage. It pulled together clouds of gas and dust, forming the first galaxies, massive collections of stars bound together by gravity. Over billions of years, these galaxies grew and evolved, colliding and merging to form the vast structures we see in the universe today. Among these countless galaxies, one in particular would come to hold special significance for us, the Milky Way. Formed around 13.6 billion years ago, the Milky Way began as a small galaxy, but over billions of years, it grew by merging with other galaxies, accumulating stars, gas, and dark matter. Our galaxy, a vast spiral of hundreds of billions of stars, is a marvel of cosmic engineering. Its spiral arms, rich with gas and dust, are stellar nurseries where new stars are born. Deep within its core lies a supermassive black hole, a cosmic behemoth millions of times more massive than our Sun. But the Milky Way story is far from over. Even today, it continues to grow and evolve, slowly merging with smaller galaxies and preparing for an epic collision with the nearby Andromeda Galaxy, a cosmic event that will occur in about 4 billion years. About 4.6 billion years ago, in one of the Milky Way's spiral arms, a new star was born. This star, our Sun, formed from the remnants of previous generations of stars, enriched with heavy elements forged in the crucibles of supernovae. Surrounding the newborn Sun was a swirling disk of gas and dust, the remnants of the cloud that had collapsed to form the star. Over millions of years, particles within this disk began to stick together, forming clumps that would eventually grow into planets, moons, and other celestial bodies. In the inner regions of the disk, where temperatures were high, rocky planets like Earth, Venus, Mars, and Mercury took shape. In the colder outer regions, gas giants like Jupiter and Saturn formed, along with ice giants like Uranus and Neptune. But the early solar system was a chaotic place, with young planets jockeying for position and frequently colliding. It was during this tumultuous period that the Moon was formed, likely from a giant impact between the early Earth and a Mars-sized body. Among the planets that formed in the young solar system, one would come to hold a special place in the universe, Earth. In its early days, Earth was a molten, inhospitable world, bombarded by asteroids and comets. But over time, as the planet cooled, a crust formed, and water, delivered by comets and outgassed from the planet's interior, began to pool on its surface. This was the beginning of an extraordinary transformation. In the primordial oceans, simple chemical compounds began to combine, eventually giving rise to the first forms of life. These early organisms were simple, single-celled life forms, but they held within them the seeds of all future life on Earth. Over billions of years, life on Earth evolved, growing more complex and diverse. Photosynthetic organisms began to produce oxygen, transforming the planet's atmosphere and paving the way for the emergence of more complex life forms. The Cambrian explosion, around 540 million years ago, saw the rapid diversification of life, leading to the rise of the first animals. From the first fish to the dinosaurs, from the earliest mammals to humans, life on Earth has been shaped by the forces of evolution, natural selection, and environmental change. Each step in this journey has been a response to the conditions of the time, leading to the incredible diversity of life we see today. Fast forward to the present day. Humans, the result of billions of years of cosmic and biological evolution, stand on the brink of understanding the universe's greatest mysteries. We've mapped the stars, walked on the moon, and peered into the farthest reaches of the cosmos with powerful telescopes. Yet, in the grand timeline of the universe, humanity's presence is but a fleeting moment. If the history of the universe were a single year, all of human history would fit into the last few seconds of December 31st. Our time on this planet is a blink of an eye in the cosmic scale, but our curiosity, our desire to explore, and our quest for knowledge drive us to look beyond our small place in the universe. We seek to understand the forces that have shaped our existence, from the Big Bang to the present, and to ponder the future of the cosmos. As we look to the future, the universe's story is far from over. Stars will continue to be born, live out their lives, and die, creating new elements and seeding new solar systems. Galaxies will collide and merge, forming even larger structures. And eventually, the universe may enter a new phase, its ultimate fate determined by forces we are only beginning to understand. Will the universe continue to expand forever, growing colder and darker as stars burn out and galaxies drift apart? Or will it eventually collapse in a big crunch, reversing the expansion and returning to a hot, dense state? Or perhaps something else entirely, something we cannot yet imagine? These questions remind us that despite all we have learned, there is still much we do not know. The universe, vast and mysterious, holds countless secrets waiting to be discovered. As you reflect on the journey of the universe, from the Big Bang to the present moment, consider the incredible scale and complexity of the cosmos. Each of us is part of this grand story, made of the same elements, forged in the hearts of stars, living on a planet that formed from the remnants of ancient supernova. The universe is our home, and its history is our history. So, let us continue to explore, to question, and to seek out the answers to the mysteries of existence. Whether you see through a telescope at the night sky, read about the latest discoveries in astrophysics, or simply marvel at the beauty of the stars, you are participating in the grand adventure of understanding the cosmos. The next chapter of the universe's story is being written right now. What role will you play in it? If you find this video interesting, please like, comment, and share with your friends, relatives, and kids who may find this fascinating. Please subscribe for more such interesting content.